This video will cover the concept of heats of reaction. Heats of reaction refer to the change in energy during a reaction under conditions of constant pressure. They help calculate the amount of heat released or absorbed. There are two main types of chemical reactions based on heat changes: exothermic reaction and endothermic reaction. An exothermic reaction is one in which heat is released from the system into the surrounding environment. Examples of exothermic reactions include neutralization reactions, combustion reactions, and the rusting process. Conversely, an endothermic reaction is a type of reaction where heat is absorbed into the system from the surrounding environment. Examples of endothermic reactions are photosynthesis, the evaporation of liquid water, and the melting of ice cubes. It is important to note that endothermic reactions are indicated by a positive sign, while exothermic reactions are indicated by a negative sign for the change in heat. Let's determine whether the following reaction is endothermic or exothermic. NaOH plus HCl yields sodium chloride plus H2O with a delta H of negative 57 kilojoules per mole. Another example: water yields hydrogen gas and oxygen gas with a delta H of positive 575 kilojoules per mole. The first reaction is exothermic because the energy change is negative. The second reaction is endothermic because the energy change is positive. The formula for the heat of reaction is delta H equals the heat in reactants minus the heat in products. Bond energy is the amount of energy required to break a bond in a molecular element or compound, measured in kilojoules per mole. This table displays various bond energies. Consider methane burning in excess oxygen to produce carbon dioxide and water, as shown in the equation. We need to calculate the overall enthalpy change for the reaction and state whether it is endothermic or exothermic. First, calculate the heat in the reactants, which involves bond breaking. The total energy is 2,648 kilojoules. Next, calculate the heat in the products, involving bond making. The total energy is 3,466 kilojoules. Applying the formula, delta H equals 2,648 kilojoules minus 3,466 kilojoules, resulting in negative 818 kilojoules. Since the heat change is negative, the reaction is an exothermic reaction. Energy level diagrams are used to represent the heat changes in chemical reactions. For an exothermic reaction, the energy level decreases, meaning the reactants are higher in energy than the products. The arrow points downwards, showing that heat is lost or given out, and the heat change is negative. This is an example of an energy level diagram for an exothermic reaction. Let's draw the energy level diagram for the exothermic reaction of hydrogen and chlorine to form 2 moles of hydrogen chloride. This diagram shows the solution for the exothermic reaction example. For an endothermic reaction, the energy level increases, meaning the reactants are lower in energy than the products. The arrow points upwards, indicating that heat is taken in or gained, and the heat change is positive. This is an example of an energy level diagram for an endothermic reaction. We will now draw the energy level diagram for the endothermic dissolution of ammonium nitrate in water. This diagram shows the solution for the endothermic reaction example.